Alright, so make sure you turn to page 131 of your workbook. We're going to go on ahead and fill in example 1, 2, and 3 as your notes. So if you are not there, pause the video, turn to page 131. If you are there, let's go on ahead and get started. The functions f of x and g of x are described below. Compare the properties of each. One thing I want you to know is that they're labeled. So the one on the graph is f of x, which means that the one in the table is g of x. I'd like you to go on ahead and trace over those just so that we know what we're talking about. When it says compare, I'm asking for a very specific thing. I want to know the rate of change. Go on ahead and write these notes in your examples as well. I want to know the rate of change, and if you look down below, you can see one other thing that I'm going to compare, and that's the y-intercept. Alright, so looking at this, if I scroll down and I take a look at number 1, it says, identify the rate of change for the first function, f of x. I'm going to double check the letters. F of x is on the graph. So I want the rate of change for the one on the graph. For rate of change, we use the formula y2 minus y1 over x2 minus x1. I'm just going to go on ahead and pick any 2 points on my graph to find the formula for. I want to pick good points. And what I mean by good points is points that are clear. Like this point right here is clearly 0, 8. And then maybe over here, 4, 0. Alright. Now that I have those 2 points, I'm going to plug them into my formula. I need my y2, so I go to the y column, the second one, 0. According to my formula, I subtract. y1, I go to my y column, first one, 8. All over x2 minus x1. 0 minus 8 is negative 8. 4 minus 0 is 4. And this reduces. Negative 8 divided by 4 is negative 2. So the average rate of change for that first one is negative 2. It says to identify the rate of change for the second function, I'm just going to go on ahead and pick 2 points from my table above. I'm going to pick 0, negative 6, and 1, negative 4. Alright, y2 is negative 4, minus y1 is negative 6. When we're minusing a minus, we know that we can change that into a plus. All of that's going to be divided by 1 minus 0. Negative 4 plus 6. You guys aren't great with those negatives, so you might want to put that in your calculator. You end up with 2 over 1, which is just 2. So far, so good. Identify the y-intercept of the first function. That's pretty easy. I just have to look at the graph. The y-intercept is the point on the y-axis. So it's this point right here. We would call that 0, 8. And the nice thing about doing the graph first is it reminds us of our pattern. Intercepts always are 0, a number, or number, 0. Looking at this, I know that my y-intercept should have the number on the y side. So when I look at my table for g of x, I'm looking for a 0 on the x side and a number on the y side. So it turns out my y-intercept's right there in the table. 0, negative 6. So now we get to the heart of the matter where it says to compare the properties of each functions. So I want to look back at all of this data that I've just collected. I have a rate of change. I notice that this one's negative 2 and this one's positive 2. So for the rate of change, I could say that f of x has a negative rate of change and g of x has a positive rate of change. Or I could say g of x has a bigger rate of change. One other thing I might want to bring up here is because my rate of change is positive, g of x is increasing. And because this one's negative, f of x is decreasing. And then I just want to say one thing about my intercepts. F of x had an intercept at 0, 8, and g of x at 0, -6. So I would say that f of x has the higher y-intercept. F of x has a greater / bigger y-intercept. And that's how you would compare your two functions.